All right, so today we're taking notes and we're titling our notes today Direct Variation. Direct variation. Our essential question today, what is the most important part in solving direct variation problems? And so we're looking at proportionality. And as we look at proportionality, we're looking at direct variation, and that's all part of it. So let's write that down first and let's kind of explain really what that looks like. So we have direct variation. In simple terms, it means as one number increases, so does the other. They're directly related. Or you could also say, or decreases as the other decreases. So as one number increases, so does the other, or it decreases as the other decreases. So they either both go up together or they both go down together. Here's the important part though, at the same rate, at the same rate. And we'll look at what that means because that really makes the problems make a lot more sense. So some examples of this might be the temperature. So if you look here, as the temperature increases, so as it gets hotter, what would be something that makes sense that would also increase? As the temperature gets hotter, the sale of sunblock also increases, or the sale of snow cones increase. So you could say, as the temperature increases, snow cone sales also increase. Or you could look at it another way. Let's say um, as temperature decreases, as temperature decreases, as it gets colder, snow cone sales also decrease. People are buying less snow cones when it gets colder. So temperature increases, there's more snow cones, temperature decreases, less snow cones. That's a kind of very rough kind of example of what direct variation means. As one goes up, the other goes up, or as one goes down, the other goes down. Now we're going to put some numbers to it. And direct variation is actually has to do with proportions. So let's go ahead and write proportions. In simple terms, proportions are equal fractions. Fractions that are equal. And by fractions, we can also look at it as ratios. So equal fractions, which really are ratios in this sense. And because they're equal, we can now figure out and solve for certain variables or certain unknowns. All right, so we have those written down. So let's look at an example here. Example number one. So go ahead and write this down with me. If X and Y are in direct proportion, so meaning as one goes up, the other goes up at the same rate, or as one goes down, the other goes down at the same rate. And I know Y is, let's say, 75 when X is 15. I need to find Y then when X is 12. Go ahead and write that down. If X and Y are in direct proportion and Y is 75 when X is 15, find Y when X is 12. Go ahead and write that problem down. So what we have to look at here is we're going to set up a proportion. Proportion is really just two equal ratios. So let's go ahead and write that. equal sign with two ratios, two fractions in essence. And the way we're going to write these ones, because we're going to do some stuff later on, I want us to get used to writing this. We're going to put a y on this side and an x on this side. Let's make it a fraction. So we're going to include our y numbers are going to go in the, remember this is called the numerator. This is called the denominator. So we're going to include the y variables on top, x variables on the bottom. So let's take a look. It says y is 75. So they're in direct proportion and y is 75. So I'm going to place 75 where y is. But y is only 75 when x is 15. So that's their direct variation. As x is 15, y has to be 75. All right, so there's a rule, there's a pattern in here. And we're going to use that pattern to unlock this mystery, which is I need to find y. So I don't know what y is. So I have to figure out, does y go on top or bottom? Well, if I look here, I said I'm going to put my y's on top. So this y is going to go in the numerator. I'm going to find y when x is 12. So there's 12. X's are going to go on the bottom. So I'm going to put my 12 in the denominator. And this is the proportion that we have to solve here. 75 over 15 equals y over 12. Now, couple ways to solve this. We're going to go over the one simple way I think is the way that works every time. We're going to cross multiply. What that means, I'm going to cross multiply. I'm going to multiply across, but I'm going to go at a diagonal. Cross multiply. So I'm going to make an x when I multiply. So 75 times 12, we'll multiply that together. And 75 times 12, let's just write that out. 75 times 12 is going to equal 15 times y. 75 times 12 equals 15 times y. Cross multiply. This is a nice easy equation now. Well, 75 times 12, that's 900. 15 times y is just 15y. And this is just a single step equation. I'm multiplying by 15. So I remember to get rid of it, I'm going to divide by 15. Divide by 15. These cancel. Y equals 900 divided by 15 is going to be 60. So find y when x is 12. Y is 12. Sorry. Y is 60 when x is 12. Y is 60 when x is 12. What's the most important part? Here's what we have to pay attention to. Make sure to keep y's with y's and x's with x's. Here's the most important part in solving proportions and direct variation problems. Make sure to keep your y's with y's and your x's with x's. Make sure to keep your y's with y's and your x's with x's. Good. Make sure you have that one written down. All right, number 2. So if x and y are in direct proportion and y is 20 when x is 10, Find y when x is 2. If x and y are in direct proportion and y is 20 when x is 10, find y when x is 2. As soon as you see direct proportion, your brain should automatically draw an equal sign with 2 ratios on each side, because that's what we're setting up. An equal sign with 2 ratios on each side. And remember, we're going to have y's over x's. Y is on top, x is on the bottom. If x and y are in direct proportion, and y is, my ears should be perking up here, y is 20. So I know that 20 is going to go with the y's, which are on top. Y is 20 when x is 10. When x is 10. So those go together. When y is 20, when x is 10. So I'm going to put that in the same ratio. Y is on top, x is on the bottom. All right, so I'm going to find y. So I don't know what y is, but I do know y's go in the numerator, not the denominator, the numerator. When x is 2. When x is 2. There we go. There is my proportion. I can solve that. I can cross multiply. Which means I'm going to take that 20 and I'm going to multiply it times 2. And that's going to equal, take that 10, multiply it by y. 20 times 2, that's 40, equals 10y. Then I'm going to divide both sides by 10. Y equals 4. Y equals 4. Good, so that's the cross multiplying way. But let me erase these arrows real quick. Go back to the original problem. Does anyone see another way we could have gotten 4 here without cross multiplying? Because there's a bunch of ways to solve this. How could we have gotten a 4 here? Yeah, if we look here, we're saying y is twice as much. It's 2 times as big than x. That's twice as big as x. So if x is 2, and it's always 2 times bigger, 2 times 2 is 4. And notice, same answer. So if you can figure out how many times bigger it is or smaller it is, you can use that same direct variation and solve the problem a little bit faster that way as well. Now, if that confuses you, you are always more than welcome to do cross multiply, and you can get your answer that way. I just wanted to show you that there's other ways to get that answer as well. All right, let's have you do 2 on your own here. Number 3. If x and y are in direct proportion and y is 5 when x is 15, find y when x is 6. If x and y are in direct proportion and y is 5 when x is 15, find y when x is 6. So as soon as I see my keyword here, direct proportion, I'm setting up my equal sign, 2 ratios. Remember, y is on top, x is on the bottom. See if you can set up this proportion. We'll come around and check as you set it up. And then you can finish solving it after we checked and made sure you set it up correctly. All right, good. So you should have gotten here. Y is 5 when x is 15. And find y when x is 6. Cross multiply, cross multiply. We get 30 equals 15y. Divide by 15. y is 2. Y is 2. The shortcut way, we could have looked here. Well, I know I need to divide 15 divided by 3 is 5. So if I could do 6 divided by 3, what's 6 divided by 3? Oh, that's 2. And notice I got 2 for my answer as well. You could do it either way, the cross multiplying or seeing the variation there. Good. All right, last one to try on our own here, number 4. If x and y are in direct proportion and y is 3 when x is 4, find y when x is 8. Good. Go ahead and set this up. Set up your proportion with your two ratios. Plug them in. When you're done, raise your hand. We'll come by and check them. All right, here we go. Set up our proportion. We have our y's over x's. So I have 3 and 4. Find y when x is 8. Cross multiply, cross multiply. 3 times 8 is 24 equals 4y. Divide by 4, divide by 4. Y equals 6. Good. And you could also check here. Look at, I know 4 is times 2 is 8. So if I times 2 this way, 3 times 2 is 6. And notice I got my answer of 6 down here as well. So there's a bunch of different ways to solve it. But like I said, cross multiplying will always get you that answer. But if you get good at it, you can see little tricks and shortcuts to solve those as well. Good. The question is, what's the most important thing? And we wrote it up here on the side. It was make sure to keep y's with y's and x's with x's. Good. Make sure you write those down. And once you do write those down, those are going to be our notes for today.